Hi there. So let's go to the lab directly. We are working on lab 7, I believe. Glacial interglacial cycles. This one. Okay. So first of all, you should watch these how many? 556 minutes video from Mila. Then they will discuss about the research question. As usual, there will be three types of question: fact based, which is exactly the same answers you are required to give, that has been there already; synthesis based, that is around the idea of the question, idea of the description. The answer shouldn't isn't directly stated, but it should be easily calculated or assumed. Like it will probably ask you, as I already told you, it will probably the description might also give you 2 plus 2. Then the question will probably ask you, what is 2 plus 2? The answer is 4. You need to calculate that number and answer based on that. So that is the synthesis based. And hypothesis based, hypothesis is also around the idea of the whole lab. What do you feel about that? Why is that question? And why is these things something happening? All you need to do is to answer on your own word. There's no right or wrong answer. Everything you say based on your own understanding is considered a right answer. But it has to be around the idea of the lab. If that doesn't revolve around the idea of the lab, then I might not be able to give you any marks for that. But usually for the hypothesis question, most of the time you get very good marks from me. So section 2 will be our starting point. As we already told you, that we are in an ice age right now. So, and right now as well, if you look at the glacial and interglacial period, we are now in the interglacial period, as we are above the mean, above the average temperature. So I'm not going to go into there at all. Just follow this description, follow this image, open it and watch this video, which will show you how the temperature reconstruction happened using the ice core. So this video will help you to understand that part, and answer question 1 based on that. Then on question 2 and subsequent question, you need to download these Excel file and follow the instruction in here. So let me do it with you for you. So I'm gonna download that one, open it, clicking on enable content. Then what it says, select cells in row 2 to 3312 of column B and C. So I'm gonna select column B and C from 2 to all the way down, 3312. Then under the insert tab, select scatter and then choose the first scatter plot. Insert, select scatter, the first one. So I already got that. So this is, you, I'm sure you already, like, you already seen that, right? But you need to adjust that a little bit. So let me follow the instruction. The second one, enlarge the chart, we already did that. Then make it up. Okay, so make it up most of your screen. Okay, fine, we already did that. Reverse the x-axis value so that 0 is on the far right. So right now the 0 is on the far left, but the one I were discussing with you, the 0 was this way, this side, and 450,000 years ago was this side. So we need to reverse that. So what we need to do, this is the axis for us. Click on right mouse button. Yeah, I believe so. Okay, so all you need to do is to, okay, so over this axis region, just click on the right mouse, click on format axis, then go down here and values in reverse order. That way You have made it the zero in the far right and the 450,000 in the far left. Okay, so and now you can, as you like, I don't even need to explain it to you. You already know what is the glacial interglacial cycle, what is the glacial maxima, what is the interglacial maxima, what is the temperature difference between the maximum, and what is the time interval between each interglacial maxima and each glacial maxima. You already all know all of those things. Just follow these and answer question 2. Are we currently in a glacial period or an interglacial period? How do you know? For these, and follow this description as well as my presentation video that already talked about that in details. Question 3, when did the most recent maximum in glacial? I already talked about that as well. And already there is answer in my presentation slide as well. What is the approximate difference in temperature between a maximum in glacial period and a maximum or preceding or succeeding interglacial period? So this one is talking about the glacial maximum, the temperature difference between the one glacial maximum with another interglacial maximum. So what you need to do, you need to pick a cycle. This, if you look at this cycle, this is the interglacial maximum and this is the glacial maximum. There is a temperature, you see, follow the temperature difference. Again, what is the approximate time interval between both maximums in glacial periods? Like maximums in interglacial periods and maximums in glacial periods. So I already told you about that in my presentation. Just follow the presentation slide. So this section 3 is little bit time consuming for you as well as really important. So for section 3, all you need to do is to click on this image that will open a section for you. Click on OK, then go down here and let me small my screen. Okay, so here you can watch the art from the oblique view. If you click on the top view, you will be able to watch the art from the top down approach. So these are the two buttons. We will use these two buttons. Then this is the rotation. If you unclick it, right now it is clicked because it's red showing it, that means it is already clicked. If you unclick it, the rotation of the art will stop. If you click it again, it will like rotate again. And then there is orbit and faster orbit. Let's look it from the top view. So if you click on orbit, it will move slowly. If you click on faster orbit, it will move fast. So that's really simple question, simple way. And then there's three options for you to check the eccentricity. If you click on eccentricity, you will be able to see the effect of eccentricity in the orbit. So change of the shape of orbit is the eccentricity. I will show you that in a moment. Then again, and I will specifically show you the idea of the eccentricity. Then you will be able to play with precision and tilt from the instruction given in the bottom. So then if you unclick it and click on precision, now you will be able to see the idea of precision. Then if you unclick it, click on tilt, play around with it. And then there is Vostok ice core, like the when they measured the temperature with the ice core. So what was the temperature and what was everything. So whenever you click on eccentricity, you see there's something that is coming up, the magenta one. So that one is actually showing you the value of the eccentricity during the time. Now the slider is on now, that means now the eccentricity is this level. If this one is the future in that up, but if you go down, it goes past and almost 400,000 years ago. So if you go past, you will see that year. If you go past almost, you see what was the year, 76,000 years ago. You see the eccentricity was really low, then it became highest again in 122,000 years ago, then it became lowest again 171,000 years ago, again highest one 2031,000 years ago, 231,000 years ago, again it became lowest during 2,275,000 years ago. That way you can, like, if you move at this, now you see, if you move at this really fast, if you look at in here, you can see the orbit is changing its shape. So orbit is not the same, you see, it's shrinking and it's going upward, shrinking and going. If you go to the highest point, you see, if you go to the lowest point, if you go to the highest eccentricity, that means the orbit is shrinked somewhat. Like, it's not actually shrinked, it's the orientation of the orbit. If you look at the oblique view, you can see it even in a different way. It's not the shrinking, it's, you see, the orientation is changing, it's moving this way, the oblique, the orbit. So let's take you through the instruction here. So to understand eccentricity, all you need to do is first select top view and orbit. I'm selecting top view and I'm selecting orbit. Then now it's in the top view, now it's in the slower orbit, and then from orbital parameters click eccentricity only. It's already clicked here, I clicked here. Drag this time slider up and down to see the shape of Earth's orbit at different times. Eccentricity is a measure of how circular an orbit is. So if you move the time slider, you see the circularity is changing. It's not completely circular or same circular all the time. It's changing over the year. And the magenta line is the graph shows how global temperature would change if eccentricity were the only orbital parameter that changed. So this is the temperature. So this is the time when the global temperature was lowest. You see the shape of the orbit, and then this is the time when the temperature was highest. You see the shape of the orbit. How does this change? So just follow with this trend and answer some of these questions. So this is eccentricity and this is the eccentricity cycle. Just answer the question of cycle. I already talked about these as well in the presentation. Then uh, just go to the, then again play with the precision tool. The instruction is there. Then play again with tilt, then compare all these things, follow the instruction. So the idea is that the The idea is that the Earth's temperature is a combination of Earth's eccentricity, precision, and tilt. So if you just consider the eccentricity, this is the temperature cycle, and Vostok ice core has this temperature cycle. So you see that this is the temperature cycle that we get the green one from the ice core, and this is how the temperature would have been if only the eccentricity factors were working. But if you put precision factors in there, it is getting almost similar to the Vostok ice core measurement. There's still some difference in here, in there as well, but if you put tilt factor as well, now you see it's almost similar. So that way we can say that the eccentricity, precision, and tilt actually works to make the temperature difference or seasonal difference and whatever it is. So follow this question, what is ephelion, perihelion? Just follow the instruction and play with this Milankovitch cycle. Milankovitch cycle consists of eccentricity, precision, and tilt. And then that section 4 is talking about obliquity, for play with that. Section 5 is talking about the precision, play with that. And there is a video to show you what is precision. You see, precision is uh, the rotation of the earth's axis. Okay, so just follow this here, and this image is also talking about the three different things: the eccentricity, the tilting or obliquity, and the precision. Hence, these I've already talked with you about these. If the eccentricity increases, the obliquity decreases, or you can say in a different way that in during 126,000 years ago, compared to 126,000 years ago, and compared to 116,000 years ago, the eccentricity increased. Like 116,000 years ago is relatively close to us from now than 126,000 years ago. So that time eccentricity was at highest, as well as the obliquity was in the lowest portion. So answer question 4 and 15 based on them, and click orbit to determine what seasons. What is that? Okay. So again, you need to go there and follow the instruction in here. And what is aphelion? What is perihelion? Just see, look at the distance. You see, these when the Earth is here, the distance between sun and earth is comparatively low than when the earth is here, distance is really high. So there is one that is called aphelion, there is one that is called perihelion. So answer your question based on them. And then I already talked with you about these. What is the relationship between, okay, so you already know the relationship that is proportional. I already told you in the presentation. What is the difference in carbon dioxide concentration parts per billion in Mexico? Okay, I already talked about all of these things. So, in my opinion, just take my word. Just focus more on my presentation video, and then answer this question. Then read the description and answer this question. It will be really easy. Okay. So then there is this animation for the LGM. I will show you the animation. Okay. So let's go to that animation first. So if we play that animation, one moment, let me hide that. Okay. Okay. So if you play this animation, so at the beginning of animation, just let me show you what's happening here. At the beginning of animation, it talks to you about 19,000 BC. 19,000 BC means 19,000. If you know the time cycle, so you know the right now we are in 2000, we are above 0 to 2022. So this is 2022, so we are 2000 years above the 0 point, and that 19,000 BC is 19,000 below the 0 point. So this is talking about 19,000 BC, where you can see the carbon dioxide concentration is this level, the rate, which is close to, so the red one is the, I guess, present one. Let me run the video first, then I'll talk to you about that again. So this is 17,000 BC, 1650,000 BC. So the more you are coming to close to zero or recent time, if you look at these ice over USA or that northern hemisphere, you can see that ice sheets are actually retreating, right? And like let's give you an example. Right now in 9,000 BC, the carbon dioxide concentration is 260 ppm, compared to the current concentration of 380 ppm. That time the temperature was 13.4 degrees Celsius, almost close to this one. That time the sea level was minus 53 meter. And what is this? I don't know what is that. You can see. Okay, let's play the video. Population. Oh, that's not a concern for this lab. So the idea is that the more we went to the current age, the more the ice got reduced, and you already know that we are now in the interglacial period, right? So the temperature should increase, which actually means that ice should be reduced, and it will get reduced again and again and again in the future as well, and at some point of time it will again start to increase, which will initiate the initiate the glacial cycle again. So now this is the idea of present time today. So today the United States doesn't have mm, any ice portion, ice covering, as well as Canada. Like these, the Greenland, the Antarctic, Arctic and Antarctic region. You see, these two regions have ice here. So this animation, after watching this animation, you will be able to differentiate between today's concentration and everything with 19,000 BC, which is 21,000 years ago. So compared to the present day global average temperature, how much lower was the global average temperature 21,000 years ago? The 21,000 years ago means 19,000 BC. And then how much did the carbon dioxide decrease from to the 1000 years ago to 1500 years? So you need to this one actually means 21,000 years ago means 19,000 BC, and then you need to measure the carbon dioxide concentration from that time. Then you go to the point of 1500 AD in the video and follow the carbon dioxide concentration and get the difference as well. And why have carbon dioxide concentration increased? In the answer lies in the albedo, why carbon dioxide actually increases. So in the albedo, in the sea level, so in the sea level as well, in the ice content. So try to accumulate your idea based around the albedo effect, based around the sea level, and based around how the carbon dioxide concentration is related to the high temperature and low temperature. So these of those things that will help you to answer question 24. And then probably this is the last, second last question, question 25. Why was the sea level so low when 21,000 years ago? Why was it so low? uh, the real idea is that 21,000 years ago there were huge amount of ice. Almost all the waters were stored in the ice, so sea level could be, should be low. So this is the right answer. I'm just giving you the answer so that you can have some idea around the question there. Then question 26, the lower sea level also contributed to a higher albedo. So this is the albedo idea. So you already studied those things in the previous labs, in the albedo lab. So just go towards those ideas and answer this question, question 26. And then there is a research question. So as I told you, uh, this video, the inst lab tour is a really I didn't make it really broad intentionally because I already talked most of those things in the presentation. Like if you watch my presentation video and then if you watch my lab video, lab tour, you can make sense. But if you just watch my lab tour, most of those questions probably won't be answered. So try to mix these two videos as well as the lab description. I believe you will be able to answer almost all of the question. That's all. See you next week.